Now, dear children, we will discuss important characteristics of stationary waves. This will be even asked in the examination also. Okay. So, although there are a number of characteristics of stationary wave or standing wave, but we discuss a few important characteristics. So, number one characteristics that we can observe under stationary wave is the disturbance does not move in any direction. So, one of the first characteristic of stationary wave is disturbance. So, wave is simply a disturbance, no? So, wave is simply a disturbance and that does not move in any direction. That means it looks stationary. That's why disturbance does not what? Move in what? Any direction. So, in case of, remember this, in case of stationary wave, whenever the wave or disturbance created, okay, that disturbance does not move in any direction. It looks stationary. So, this is one of the first characteristics of stationary wave. Number two is no energy is transferred from particle to particle. No energy is transferred. Okay, no energy is what? Transferred from particle to particle. That means the energy remains conserved, no problem. Okay. But as the wave which remains stationary, okay, due to the no transfer of particles or no disturbance or created in any of the direction, the energy is also not transferred from particle to particles. Okay, that's why such type of wave is called stationary wave or standing wave. That's why stationary wave does not advance in a medium but remains steady at that place. That's why the word stationary or standing wave is used. Okay, but remember this, in case of stationary or standing wave, no energy is even transferred from particle to particle. So this is number two. Now we have number three. All particles perform simple harmonic motion except node. So I write down all particles performs simple harmonic motion except the particles at what? Except the particles at node. Because you know at node the particle will completely at rest. There is no displacement of particle. But other than the particle at node, other particles have a displacement with a varying amount. That's why this particle, other than the particle at node, acquire what type of nature? Simple harmonic motion. That's why all particles perform simple harmonic motion except the particles at node. This is number three. Now we go to number four. The amplitude becomes zero at node and maximum at antinode. That means the amplitude of wave, write down the amplitude of wave, okay, becomes zero at node and maximum, the amplitude become even maximum at what? Antinode. So as I said already, antinode and node are the 2 points where there is no displacement and the displacement is maximum. Okay, so when we talk about the displacement, maximum displacement of the particle, the maximum displacement is also called what? Amplitude. That's why the amplitude of wave is always zero at the node, no displacement, no amplitude, whereas the amplitude become maximum at the antinode. So this is a maximum amplitude. So maximum displacement means the amplitude, there is no amplitude at the node. So this is number 4 property. We have number 5 property, and number 5 property is there must be an antinode between two consecutive nodes. Yes, there must be an antinode between two consecutive nodes. So in case of stationary wave, this node and antinode are always formed, children, but there must be an antinode between two consecutive nodes. Like see, these are two consecutive nodes, but between two consecutive nodes, what is there? Antinode. Two consecutive node and antinode. Two consecutive nodes, antinode. Again, two consecutive node, antinodes. Or we can also call there must be a node between two consecutive antinode. Two consecutive antinode, node. Two consecutive antinode, node. So this is also the characteristic of stationary wave. Even we have number 6 characteristics, children, and number 6 characteristics is nothing but the distance between two consecutive nodes or even two consecutive antinode must be lambda by 2. Now out here lambda means, this symbol is lambda, this lambda means actually the wavelength of wave, the sound wave. So because sound is propagated means the wavelength of sound wave. Okay. Similarly, the distance between antinode and the node is lambda by 4. So this distance is always same for stationary wave which is formed in any of the medium, any of the bounded medium. Okay, whether it is for rigid or whether it is for free or both rigid or both free. Okay, but remember this, the distance is always lambda by 2, and this distance is the distance between two consecutive antinode or node, and distance between antinode and node is always lambda by 4. For example, let me just show you with the help of example. Distance between this node and node, antinode, is this two consecutive this is node and node, distance lambda by 2. Even this node and this node distance will be lambda by 2. Even this node and node distance will also be what? Lambda by 2. Even this node and node distance is also what? Lambda by 2. But at the same time, if you measure this node and antinode distance, this will be lambda by 4, half of this distance. Now there are even other characteristics also. Let me just brief what are the characteristics of this simple stationary wave. In the other characteristic, if you see, during the formation of stationary wave, node and antinode are always formed. Means when the stationary wave produces, okay, remember this, antinodes and nodes are always formed, but it always form in an alternate manner. Like one node, antinode, after that one node and another antinode, it always form. Similarly, amplitude of particles are different at different points. Yes, the wave, stationary wave which produces, the particle which have amplitude are not same. That means it looks exactly like a wave having different amplitude, and there will be no amplitude at the node, as you know, and there is maximum amplitude at the antinode. But other than node and antinode, the amplitude are even different as compared to node and antinode, which means the amplitude of particles are also different at different points. Next, the maximum velocity is different at different points. That means the particle acquire a velocity, and this velocity of the particle are different at different points, and this maximum velocity of the particle are also different at different points. And lastly, the particles in particular in segment between two nodes vibrate in same phase, while particles in neighboring segment vibrate in opposite phase. This means if particle is at one node, another is particle at this node, the particle present in these two nodes vibrate in the same phase, where the particle at node and particle at antinode vibrate in different direction, in different displacement. That means they vibrate in different phase. That means the displacement particle are different in different direction in different points of this node and antinode. But between the segment of two nodes, like one node is outer and one node is outer, okay, the particle has the ability to vibrate in the same phase, and whereas in the opposite part, like antinode and node, the particles have a ability to vibrate in opposite phase. Opposite phase means the displacement of particle acquire direction of displaced particle can acquire in opposite direction. So these are the characteristics that we have learned in this particular topic called characteristics of stationary wave. Now in the next video, basically you learn the equation of stationary waves.